So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over probability with a focus of and or rule questions, and this kind of links in with probability tree diagrams. So if you're not familiar with probability tree diagrams, I'd recommend you watch that video before watching this one. Now when combining events we can use such words as and or. You can also use with, but with this we're just going to stick with and or. Now when using these words in probability, to find the probability of these combined events, we add the probabilities for when we're using or, and we multiply for probabilities for when we're using and. Now the reason for this is with or you're always increasing the number of required outcomes, and with and you're actually decreasing the number of required outcomes. Now if that makes absolutely no sense, let's have a look at this example here. So for example, let's just imagine that we are rolling two die and we're just going to see what they are. Now obviously if we're looking for a 6 on the first die or a 6 on the second die, well 6 on the first die, so let me just label this as the first die and this is the second die. Now if I'm going for a 6 on either the first or the second die, then I want this one, 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 and this one. And actually we're actually going to do this one twice, so that's going to be like so. Now in terms of all the boxes that are either highlighted in red or with a cross of a blue, then you can see that I've got around about 11 or 12 depending on how you're counting them. Now if I was going for and, if I just get rid of all of those X's, now if I'm going for a 6 on the first die and a second on the second die, then you should be able to notice that I'm only going to be able to highlight one box. So here I've absolutely limited my number of numbers of actual outcomes that I actually want. So with or, it's always going to be a large probability, or you're making the probability bigger because you're offering more chances of what you're wanting, whereas and you're actually decreasing the number of possible outcomes because you're making it more difficult for that event to actually happen. Now before we get started on these questions, just a quick reminder that you can get a copy of these questions in the description below for you to download and have an attempt at before working through this video and going through the answers. So let's have a look at an example question. So this first question says that a bag contains 3 red marbles, 4 blue marbles. A marble is taken at random from a bag and then replaced. Another marble is then taken from the bag. Work out the probability that the 2 marbles taken from the bag are the same colour. Now, again, with these types of questions, there's no indication of you having to draw a diagram, although some of you may find it easier to actually do just that. So when you're thinking about combining events, I would always opt for a tree diagram. So in terms of my first selection, I could either go for a red or I could go for a blue. And then in my second selection, again, I've only got 2 possible options, which are red and blue, red and blue. Now, in terms of filling in the probabilities, the probability of selecting a red is going to be 3 out of 7, and the probability of selecting a blue is going to be 4 out of 7. Now, once I've taken a counter from the first sort of selection, I'm going to put the counter back in. So, or the marble back in, I should say, not counter, the marble back in. So therefore, in the second selection, I'm still going to have 3 out of 7 red, and 4 out of 7 are still going to be blue. So I've just kind of quickly completed my tree diagram, and in terms of the outcomes, this is red red, this is red blue, this is blue red, and this is blue blue. Now in the question it's saying we want to select a possibility of having 2 of the same colour. So either I want to work out the probability of having red and red, or the probability of selecting a blue and a blue. Now from this, the probability of selecting a red is going to be 3 out of 7 and means multiply. So that's the first one. Or means plus. Now the probability of selecting a blue is 4 out of 7 times 4 out of 7. And then if I work that out, I'm going to have 9 over 7 plus 16 over 7, out of 49 rather. Now where I'm going with that. 49 and 49. Giving me a final answer of 25 over 49, and that doesn't simplify, so that would be my final answer. Now I could have easily done that without using a tree diagram, but again, it's entirely up to you. Sometimes a tree diagram helps you have more of an understanding, allows you to get the right fractions, the right probabilities, grouping them together, and then just make sense of the question. But again, what you don't want to do is spend too much time doing work that's unnecessary. So moving on to question 2, it says Sheila either walks or cycles to school. The probability that she walks to school is 0.65. If she walks, the probability that she's late is 0.4. If she cycles, the probability she's late is 0.1. Work out the probability that on any one day, Sheila will not be late for school. So again, let's set up our tree diagram for this. So again, our first situation is either she walks or she cycles. And then it's a case of either being late or not late, late and not late. So what we need to do is remember that all of these events are exhaustive. So in other words, that's either one or the other, and the total probability of both combinations has got to add up to 1. So the probability that she walks to school is 0.65. So that means the probability that she cycles is going to be 1 take away that, which is 0.35. Now, if she walks to school, the probability she's late is going to be 0.4. So that means the probability she's not going to be late is going to be 0.6. And if she cycles, the probability that she's going to be late is 0.1. So therefore, the probability that she's not going to be late is going to be 0.9. So in terms of what the question is asking for, it's asking for the probability that she's not late. So either she can walk and not be late, or she can cycle and not be late. So converting this into the probabilities and in what each of them means, so I've got 0.65 times 0.6 plus 0.35 times 0.9. And for this, all I need to do is put this into my calculator. So I've got 0.65 times 0.6 plus 0.35 times 0.9. And that gives me an answer of 141 over 200, which as a decimal gives me 0.705. So any of those two answers would be absolutely fine. Then moving on to question 3, it says that Peter has 12 coins in her bag. There are 3 £1 coins and 9 50p coins. She takes 3 coins at random, out the bag at random. Work out the probability that she takes exactly £2.50. Now for this, she's either going to have, well, in order, if she's only picking 3 coins and she's only got pound coins or 50p, the only way you're going to get £2.50 is having £1, £1 and 50p. Now, one thing that you then need to remember is that there are several combinations I could get £2.50. So for example, I could have £1, £1, 50p. I could have £1, 50p, and then £1. And I could also then pick 50p, £1 and £1. So there's 3 possible combinations. So for this, if I just label each of these #1, #2, #3, and again it's either those or. So in terms of #1, the probability of selecting a pound first is going to be 3 out of 12 times, and then I've got another pound. So how many pounds are going to be left? Well, there's 2. And how many coins are going to be left if I've already selected 1? Well, there's going to be 11 coins. And then how many 50p are there? 9. And if I've already selected 2 coins, how many coins are going to be left in the bag? Well, that's going to be 10. Then with #2, again, probability of selecting a pound as my first coin is going to be 3 over 12. Then obviously I've only got 11 coins left. And how many of those are 50p? Well, 9, because I've not selected one yet. And then in the third choice, I've only got 10 coins left. And how many of those are pound coins? Well, that's going to be 2. And then with option 3, I've got 50p first, so that's going to be 9 over 11. Then I've got 10 coins left in my second choice with 3 pound coins to choose from, and then 2 and 10. And what I then want to do is add all of those 3 combinations together. Now, one thing you should notice is that although the fractions are slightly different, all 3 numerators and all 3 denominators are the same. So technically, what I could have done is just worked out the one fraction or one line and then multiplied it by 3, because all of these fractions are going to equal the same amount. So all I then need to do is just simply type that all into my calculator. So I've got 3 over 12 times 2 over 11. And I'll say there's really no need for you to simplify any of these fractions while you are working them out. So there's only really one that you can simplify, which is 3 over 12 or 9 over 12, which I don't think is an option, but I can see that I've definitely made a mistake here. So let me just correct that. So that should be 12, 11 and 10. And doing just that, I get, so each of these are 9 over 220. And then just need to add those three up. So 9 over 220 times 3, or 3 of them together. And that comes up to a total of 27 over 220. Or if I write that as a decimal, it's going to be 0.1227, which is 0.1222 decimal places. Then moving on to question 4, it says the table below shows 3-day rain forecast for Friday, Saturday, Sunday in Aberystwyth. Now, for question A, it says work out the probability that it will rain on all 3 days. So we want the probability that it rains on a Friday, which is 0.7, and Saturday, which is 0.7, and Sunday. So it's going to be 0.7 times 0.7 times 0.7, or 0.7 cubed. And that gives me an answer of 0.4343. Then moving on to question B, it says work out the probability that it will rain on exactly 2 consecutive days. Now, for it to rain on 2 consecutive days, it's either got to rain on Friday and then Saturday, but not on Sunday, or we can do not Friday, Saturday, and Sunday it rains. So again, if you did a tree diagram, you'd have to make sure you're going from one branch and there'd be 3 stages to it. So for this, and again, let me just quickly go through what the tree diagram would look like. It would look something like this, where this would represent Friday, this would represent Saturday, and this would represent Sunday. Now, for it to be 2 consecutive days, I need 2 R's joined together in the final sort of outcome. So this would be one of them, because I've got my 2 R's. This one wouldn't, or this one would rather. Well, I don't actually have to may label that one wrong. That should be R there. And that should be R, and that should be R1. So that one is fine. The third one is going to be R, not R, and R. That doesn't count. So basically, the 2 possible options I'm going to have are going to be going through this path here, or this path here. But from this, what we can then do is work this out. So the probability of it raining on Friday is going to be 0.7. The probability of it raining on Saturday is going to be 0.7. But the probability of it not raining on Sunday is going to be 0.3. Plus, then, the probability of it not raining on Friday is going to be 0.3. The probability of it raining on Saturday is going to be 0.7. And the probability of it raining on Sunday is going to be 0.7. So then from this, if I then just type that all into my calculator, so 0.7 times 0.7 times 0.3 gives me an answer of 147 over 1,000, or 0.147. And that's going to be exactly the same. And if I then add those 2 numbers up, I get an answer of 0.294. Then moving on to question 5, it says the bag contains 11 counters. 5 of the counters are white. A counter is taken out the bag at random and not replaced. The second counter is taken out the bag at random. Calculate the probability that only one of the counters is white. So now the key word in this is that it is not replaced. So in this particular question, let's just do a quick tree diagram. So it's either going to be white or not white. And then the second one is white and not white, and white and not white. So in this, we've got 5 of the 11 counters going to be white, so 5 out of 11. So that means 6 of the 11 are not going to be white. Then if I've selected a white one in the first go, then that means I've got 4 left out of 10 counters. And in terms of non-whites, well, I've still got 6 of those, and that's going to be 6 out of 10. Then if I selected a non-white one first, so then how many white ones have I got? Well, I've got 5 out of 10. And how many non-whites? Well, I've already selected 1, so I'm going to have 1 less. So that's going to be 5 out of 10. Now the question's then asking, work out the probability that only one of the two counters is going to be white. So either I could have white and not white, or not white or white. And that should be an and. So they're the only 2 possible combinations where I'm only going to have 1 white counter. So looking at this first one, so white and not white is going to be 5 over 11 times 6 over 10 plus, and it's going to be 6 over 11 times 5 over 10. Now you tend to find that on non-calculator papers, I would recommend you stick with fractions because it's a lot easier to work out and multiply and add fractions than it is to multiply them. So here I'm going to end up with 30 over 110 plus 30 over 110. And that gives me a total of 60 over 110, which is 6 over 11. Then moving on to question 6, it says that Sarah has 20 sweets. She has 12 licorice sweets, 5 mint sweets, and 3 humbugs. She's going to take at random 2 sweets, work out the probability that the 2 sweets will not be the same type of sweet. So for this, we're looking at, now we're guessing that it's not going to be with replacement, so she's not going to pick up a sweet and then put it back. She's going to select 2 sweets. So we want the probability that they're not the same. So either I can have, now let's try this without drawing a tree diagram. So either I could have a licorice and mint, or I could have licorice and a humbug. I could also have a mint and licorice, or mint and a humbug, and I could also have humbug and licorice, or humbug and mint. So they're the 6 possible combinations that I could have. So licorice first is going to be 12 over 20 times mint, which is 5 over 19, and let me just put that in brackets. Then for the second one, licorice is going to be 12 over 20, and then humbug is going to be 3 over 19. And then mint and licorice is going to be 5 over 20 times, and licorice is 12 over 19. And then mint and humbug is going to be 5 over 20 times 3 over 19. Humbug and licorice is going to be 3 over 20 times 5 over 19. And, oh no, it's going to be 12. That should be a 12. And finally, for humbug and mint, it's going to be 3 over 20 times, and it's going to be 5 over 19. And what I then want to do is just simply add all of those up. So working that out, if I just do 20 times 19 first, I can get my denominator. So this is going to be over 380. So this equals 60. That's going to equal 36 over 380. That's going to be 60 over 380. That's going to be 15 over 380. This is going to be 36 over 380. And finally 15 over 380. And then all I then need to do is add up all of those fractions together. So I've got 60 plus 36 plus 60 plus 15 plus 36 plus 15. And that gives me 222 over 380, and that simplifies to give me 111 over 190, or even as a decimal it will give me 0.58 to 2 decimal places. Moving on to question 7, it says that a bag contains n counters. 1 counter is blue and the rest are red. 2 counters are taken at random from the bag. Express in terms of n the probability that a counter of each colour is taken. Give your answer as a fraction in its simplest form. So with this, we've got our total equals n. Now in terms of blue counters, that's just going to be 1, and the rest is therefore going to be n minus 1. So that's the total amount rather than the probabilities. So looking at this, we want to express the probability that a counter of each colour is taken. So either I want a blue and a red, or a red and a blue. So from this, well actually let me change, it's not rest, it's red, equals n minus 1. So the probability of selecting a blue one is going to be 1 over n times, now the probability of selecting a red, well how many red ones are there? Well there's n take away 1, and how many counters are going to be left if I've taken 1 from n? Well that's going to be n minus 1, plus the probability of selecting a red one is n minus 1 over n, because that's how many I've got in total, times how many blue ones have I got? 1, and how many have I got left in the bag? Well I'm going to end up with n take away 1. Now if I simplify each of these things, I end up with 1 over n plus 1 over n, because obviously what you tend to find is that if I do this, so this both cancel and that just equals 1, and this cancels with this, so again I'm just left with 1 over n, and that equals 2 over n, which is our final answer. For B, it then says the probability that a counter of each colour is taken is 0.125. How many red counters are in the bag? So for this, what I need to do is make 2 over n equal to 1.25. Then if I then do, so n is going to equal 2 over 0.125, so n equals 16. Now the question is asking how many red counters are there? Well, the number of red, if you notice, is n take away 1, so it's going to be 16 take away 1, so the answer then is 15. Then moving on to question 8, it says that the probability that Aaron goes to the gym on a Saturday is 0.8. If Aaron goes to the gym on Saturday, the probability he goes on Sunday is 0.3. And if Aaron doesn't go to the gym on Saturday, the probability that he goes to the gym on Sunday is 0.9. Calculate the probability that Aaron goes to the gym on exactly one of the 2 days. So for this, we can either, again, we can draw a tree diagram. So we can say this is Saturday, this is Sunday. So goes to the gym, doesn't go to the gym, goes to the gym, doesn't go to the gym, and goes to the gym, doesn't go to the gym. So again, we've got the probability he goes to the gym on Saturday is 0.8, so that's going to be 0.2. And the probability that he goes to the gym on Saturday, if he's already been, is going to be 0.3, so that's going to be 0.7. And if he doesn't go, the probability he goes to the gym is going to be 0.9, so that's going to be 0.1. So if I was going to go for the probability tree route, this is the diagram that I would then have. Now the question is asking what's the probability that he goes to gym on exactly one of the days. So the possible outcomes I could have is either G and not G, or not G and G. So that's what I then need to work out. So again, not really essential for you to draw the Venn diagram. So goes to the gym, which is 0.8, and then doesn't go to the gym, which is 0.7, plus doesn't go to the gym and then goes to the gym. So that's the calculation I then need to work out. Now this is going to give me an answer of 0.56, and this is going to give me an answer of 0.18, and then just simply adding those numbers up, so 0.56 plus 0.18 gives me an answer of 0.74. And again, I would stick with giving your answer as a decimal simply because the components, the probability they've given me in the question are in decimals. But again, if I did give it as a fraction, not really a problem. So moving on to our last example, it says the box contains 10 pins, 3 are blue and 7 are green. 2 pins are taken at random without replacement, so again we're not putting them back. And it says work out the probability that both pins are the same colour. So for this we're either going to have blue and blue, or green and green. So looking at this probability, the probability that the first one's going to be blue is 3 out of 10. Now the second one I've got 1 less, and I've also got 1 less blue, so that's going to be 2. Plus the probability of selecting a green one is 7 over 10, times I've only got 9 counters left. I've also got 1 less green one because I've assumed I've taken a green one first, so I've got this. So simplifying this, what we get is 6 over 90 plus, and it's going to be 42 over 90, which then gives me 48 over 90, and I can simplify that as being 8/15. And there is my final answer. So hopefully using the and or rules and going through the several examples that we have has kind of made sense of what we need to do. Also, I've kind of given you an indication of when a probability tree diagram could be useful. It's not essential. The questions haven't even asked me to draw a tree diagram. But again, if you find it easier to do so, then do so. The most important thing is that you're getting the questions right and you're showing some mathematical evidence to support how you're getting your answer.